Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Carbocation stability is governed by I. Degree of substitution, tertiary, secondary, primary, 2. Resonance conjugation, allylic, dienylic delocalization, and 3. Hyperconjugation. The more resonance structures that delocalize the positive charge and the more substituted the cationic carbon, the more stable the carbocation. Moving on to the next step. Option A. The positive charge is on a carbon that is part of a conjugated diene system. The cation is flanked by 2 double bonds, one on each side, making it a cross-conjugated or dienyl carbocation. However, looking at the structure, the charge is at an internal position with a methyl substituent, giving allylic stabilization, but the substitution pattern limits extended conjugation. Option B. The positive charge is on a carbon that is allylic to a double bond and is part of an extended conjugated system. The cationic center is secondary tertiary, and importantly it sits within a system where the charge can be delocalized over multiple carbons through to conjugated double bonds, A to carbon extended delocalization, C plus, C is equal to C is equal to C. Additionally, the cationic carbon has an isobutyl substituent providing hyperconjugation. This gives maximum resonance delocalization plus substitution, making it the most stable. Option C. The positive charge is on a carbon adjacent to a double bond, allylic, and bears substituents, but the geometry places it at a vinylic-like or less effectively conjugated position compared to option B. Option D. The positive charge appears to be on a terminal or less substituted carbon at the end of the chain, away from the main conjugated system, providing less stabilization. Moving on to the next step. In option B, the carbocation is stabilized by extended allylic conjugation across a diene unit. The charge is delocalized over 3 carbons via 2 double bonds, C is equal to CC is equal to CC, plus, allows resonance to spread the positive charge, and the carbon bearing the charge has alkyl substituents contributing hyperconjugation. This combination of extended conjugation plus substitution makes B the most stable carbocation among the 4 options. And for the final step, A has good conjugation but less extended delocalization than B. C and D have the charge in positions with less effective delocalization or lower substitution. Therefore, the correct answer is B. Therefore, the correct answer is option B.